Hello, Mrs. Hatfield here for daily math practice for week 12, day 3. It is Wednesday for you guys. So let's go ahead and get started. Remember that you have opened this video in YouTube, that you were pausing and solving yourself and then kind of checking your work after you've tried to see if you used my strategy. Or if you need my strategy to help you to start off, so you're not guessing, feel free to do that too. So number 1 says Mrs. Smith wants to give 2 hot dogs to each of her 32 guests. Hot dogs come in packages of 10. How many packages of hot dogs will Mrs. Smith need to buy? So let's reread that problem, see what we need here. We've got to give 2 hot dogs to each of her 32 guests. So if I imagine that over here, here's 32 of her guests, and each of them are going to get 2 hot dogs. And the second part says hot dogs come in packages of 10. How many packages of hot dogs will Mrs. Smith need to buy? So let's first find out how many hot dogs she's going to need. So we need to know 32 guests. It's good to get in the habit of labeling these things. 2 for hot dogs. Kind of sloppy with my mouse here today. Sorry about that. So that becomes 64. 2 times 2 is 4. 2 times 3 is 6. So 64 hot dogs is what she's going to need. And if we know that they come in packages of 10, a couple different strategies you can use. You can start with, if you know the total of the hot dogs, and you know they come in 10 per pack, how many hot dog packages will they need? So 10 goes into 64 6 times, because 6 times 10 is 60. But, there will be people not getting a hot dog if she only buys 6 packages. So she needs 7 packages to be able to feed all of her 32 guests. I do not think this is a party that's happening during COVID times. Question number 2. Stella is using grid paper to make shapes. Her first shape has an area of 72 square units. Her second shape has an area of 60 square units. Her third shape has an area of 48 square units. If this pattern continues, what will be the area of her fourth shape? So we don't really need to know that what shape she's making. The important thing is that she's drawing these pictures and it is showing our area. Oops, this is the wrong one. Sorry about that. So her first shape has 72. Her second shape has an area of 60 square units, then 48 square units. And if this pattern continues, what will be the area of her fourth shape? So you're seeing your pattern here, and you can see that it's a decreasing pattern. And it's decreasing. To find out how much it's decreasing by, subtract to figure out what the next number would be in this pattern. Question number 3. Which pair of line segments appear to be perpendicular? Remember, perpendicular are up and down. So perpendicular would be like something. That's the symbol that goes with perpendicular. So is it line segment BC and line segment AD? Or is it line segment CD with line segment BC? Moving right along. We are now rounding a really big number, 2,380,325 to the nearest 100,000. So first thing, let's go with our order of numbers. We go ones, tens, hundreds, 1,000, 10,000, 100,000. So I'm looking at the 3, and what number am I looking to the right of? So my first number, if you recall, We're not rounding to the millions place, we're rounding to the 100,000s place. So is the 3 going to stay a 3 or is it going to become a 4? Same thing for this number. Round 474,208 to the nearest 100,000. So find the 100,000 place. Look to the right. Remember, if it's between 0 and 4, it stays. If it's between the number to the right is between 5 and 9, it increases to the next place value. Number 5, getting these angle measurements and angle names down. What is the measurement of the angle? Choose the best estimate. So we can kind of see that it's an acute angle. So what's the best estimate for that angle? Question number 6, we are converting the fraction greater than 1 into a mixed number. So this is our improper fraction. Improper means because the 13 is greater than the 8. That's why it's called improper. And we need to convert it to a mixed number. So let's visualize what's happening here. We've got 13 eighths. And if we count out our 13, there's 8 eighths. 9, 10, 11, 12, 13. So if I'm looking at this picture, 1 is full, and how many are left over? The other way to think about this, if you might see it written like this, 8 eighths is 1 whole plus 5 eighths makes 13 eighths. Moving right along. Converting some measurements, if 3 meters is equal to 300 centimeters, how much is 1 meter? Same thing here. If how much is 5 meters in centimeters? A little science question there. Getting better and better at these, using partial products to do this. 3 times 7, you might want to pause and solve. We're just using the partial products model to do this. 7 times 8 tenths. Hopefully you've paused and you're checking your work now. 2 tenths times 3 is the same thing as 20 times 3. So if 2 times 3 is 6, then 2 tenths times 3 would be 60. And then 2 tenths times 8 tenths, well, 2 times 8 is 16, and since I have 2 tenths, I need to account for those 2 zeros. Okay, be super careful when you're adding these up. You might have a little bit of place value issue if you don't have everything lined up correctly, and then just add them up. Thanks for watching. I hope you have a wonderful Wednesday. If you're in cohort B, I will see you tomorrow. Yay! If you are in cohort A, I'll see you on Monday. Don't forget to do your work each day and complete your iReady time. Have a great day.